Have you ever just stared at a huge pile of text? I mean, like endless pages of clinical notes, or maybe these really dense legal documents.
Oh, yeah. Or even customer feedback, right? Just streams of it.
Exactly. Or just trying to keep up with news reports every single day. You know, there are critical insights hidden in there, but they feel completely locked away.
Totally inaccessible.
I remember trying to sort through a year's worth of just chaotic meeting notes once. I knew vital decisions were buried somewhere, but finding them, nightmare.
It's a massive hurdle, this problem of information trapped in unstructured text. We're swimming in data, but accessing the valuable bits is tough.
And just trying to sift through it manually.
Yeah.
Forget it.
Oh, it's not just time consuming, it's so easy to make mistakes. And, even with modern large language models, LLMs, just feeding them raw text can cause problems.
Like the hallucination issue.
Exactly. They can generate stuff that sounds plausible but is just wrong. It's like having this brilliant assistant who sometimes just makes things up. So it makes being truly well-informed incredibly difficult when you need precise, trustworthy facts from all that noise.
Right, that's the real challenge. So what if?
Yeah.
What if you could programmatically pull out the exact information you need
Okay.
and, crucially, ensure the output is structured, reliable, and you can actually trace it back to the source, like prove where it came from?
Now that would be something.
Well, that's basically the mission for our deep dive today. We're going to explore a new solution built for exactly this problem.
And that solution is LangExtract. It's a powerful new open source Python library.
Okay, LangExtract.
Yeah. Its whole purpose is to let developers process huge amounts of this unstructured text and turn it into structured, usable information. It uses advanced LLMs, things like Google's Gemini models, with a big focus on being flexible and, really importantly, traceable, knowing where the info came from.
And I'm guessing even though it's a developer tool, the impact is much broader.
Absolutely. Whether you're, prepping for a big meeting or trying to get up to speed on a complex topic fast, or honestly, even if you're just curious about how tech is changing information access.
Yeah.
This deep dive is kind of a shortcut. You'll get a real sense of how this tool can unlock data that was basically trapped before in pretty much any field you can think of that deals with lots of text.
Okay, let's really get into it then.
Yeah.
There are other extraction tools out there.
Hmm.
What makes LangExtract, stand out? What's its secret sauce?
Well, one of the truly remarkable things is what they call precise source grounding.
Precise source grounding. Okay.
And it's not just some technical jargon. It's actually a game changer, especially for critical fields. Basically, every single piece of information LangExtract pulls out.
Yeah.
It's meticulously mapped back to its exact character position, the offsets in the original text.
Wait, so it's not just saying I found this, it's saying I found this right here.
Precisely, like giving you the page number and the exact spot on the line.
Wow. Like a highlighted version of the original document, almost like a forensic trail.
That's a great way to put it. It provides incredible traceability. Think about auditing a legal doc. Every fact comes with that precise location.
Okay, I can see how that changes things.
You can visually highlight every extraction right in the source text. It makes evaluation, verification so much easier. It helps avoid that whole black box problem where you just cross your fingers and hope the AI got it right.
Right, you have proof. You can see it.
You have the proof right there.
That traceability.
Yeah.
Yeah, that feels fundamental for reliability. But, okay, my experience with LLMs is that getting reliably structured output is tricky. They like to be creative.
Yeah, they can be. Which is sometimes great, but not when you need a clean spreadsheet, right?
Exactly. So how does LangExtract nail down that consistency, that structure?
That's where its approach to reliable structured outputs comes in. It's pretty clever. Developers define the exact output format they want using LangExtract's own way of representing data. Then, and this is key, they provide just a few examples. Few shot examples.
Few shots, so not like thousands of examples.
No, exactly. Maybe just a handful of really good ones showing what you want. LangExtract uses these to guide the model, basically enforcing a strict schema or structure on the output.
Oh, okay.
And it gets really powerful when it uses something called controlled generation, which is supported in models like Gemini.
Controlled generation. That sounds like how you tame the creativity you mentioned.
That's essentially it. It forces the LLM to stick to that predefined structure you gave it with your examples.
I see.
So the output is consistently clean, usable, not just free-form text. And they've shown this works really well. They did a full text analysis of Romeo and Juliet.
Romeo and Juliet.
Yeah.
The whole play.
Yep. It's long, it's complex, and LangExtract could reliably pull structured data like characters and relationships right out of it.
That's a pretty impressive test case. And it brings up another big challenge, really long documents.
Mm.
You mentioned Romeo and Juliet. What about, say, a 1,000-page report? How does LangExtract handle that kind of scale without missing things?
That's a critical point. This gets into optimized long context information extraction. Because, LLMs are amazing, but they're not perfect with super long texts.
Right.
There are these tests, like the needle in a haystack test,
Ah,
where you hide a piece of information in a huge document. And what they find is that the LLM's ability to recall facts, especially multiple facts,
hmm
can actually go down as the text gets longer and longer.
So it might just forget what it read earlier, like miss something buried deep.
Kind of, yeah. It's easy for a detail on page 10 to get lost by the time it hits page 800. It's a known weakness.
The Achilles heel of long context LLMs.
Pretty much. LangExtract is built specifically to tackle this. It uses smart strategies. It doesn't just try to read the whole thing at once.
Okay, so what does it do instead?
It intelligently chunks the document, breaks it into smaller, more manageable pieces.
Right, chunking.
Then it processes these chunks, often in parallel, to speed things up. And it might make multiple passes, focusing on different types of information extraction on each pass over these smaller, focused contexts.
So it's not one giant hopeful read-through, it's more strategic.
Exactly. It's a multi-stage attack, you could say. This makes sure that even some obscure detail buried deep in a massive document gets found reliably. This is where a lot of simpler approaches can fall down.
That multi-pass focused approach makes a lot of sense for complex tasks. Okay, so it finds the data, it structures it reliably, it handles long docs. But then what? Are you just left with, like, a data file? How do you actually use or review what it's done?
That's another really neat part. LangExtract doesn't just give you raw data. It can actually transform the original text and all the extracted bits into an interactive HTML visualization.
Interactive, like in a web browser.
Yeah, exactly. A self-contained HTML file. You can generate it in minutes. And it makes it super easy to review all the extracted entities and context. You see the original text, you see the highlights, you can explore it.
Oh, yeah.
And it's built to handle thousands of annotations without becoming slow or unusable, which is a huge time saver for anyone who needs to actually evaluate the quality of the extraction. It saves hours of manual checking.
So you get the structured data and interactive audit tool. That's powerful. What about flexibility? Which LLMs can you use? And can it handle any type of text, any domain?
Yeah, flexibility is a big design goal. So flexible support for LLM backends and domains. You can plug in your preferred models, could be cloud APIs like Gemini, or even open source models running locally on your machine.
Okay.
And critically, yes, it's flexible across domains. You don't need a model pre-trained on legal text or medical text specifically.
So how does it adapt?
You define your specific extraction task, what you want to pull out, using those few shot examples we talked about. You give it a few good examples for, say, medical data or financial data or whatever.
Right.
And LangExtract essentially learns what you want from those examples without you having to fine-tune the underlying LLM, which is a complex process.
Yeah.
Then it can apply that learning to new large documents in that domain. Super versatile.
That few-shot approach makes it really accessible then. You don't need massive data sets or ML expertise to tailor it.
Okay, one more thing on capabilities. Does it only pull out what's explicitly written? Or can it use the LLM's, general knowledge, its world knowledge?
Good question. Yes, it can leverage the LLM's inherent world knowledge.
How does that work?
Well, it means LangExtract isn't just a simple pattern matcher. It can act more like an intelligent agent. It might infer connections or add context that isn't literally spelled out in the text.
So, maybe it extracts a medication name from a clinical note. Based on its training data, the LLM might be able to infer common dosages or perhaps potential interactions, even if the note didn't state them.
Ah, I see. It adds another layer.
It does. But, and this is important, the accuracy of those inferences really depends heavily on the quality of the LLM you choose and how carefully you craft your prompts and examples.
Right. You need to guide it carefully if you want it to infer things reliably.
Exactly. It's about giving the model the right context to use its deeper knowledge safely and accurately.
Fascinating. Okay, so we've covered the how. Let's talk about the what. What does this mean in practice? How are people actually using this? Where does the rubber meet the road?
Well, a really accessible starting point they use in their quick start guide is actually analyzing literature.
Like the Shakespeare example.
Yeah. Imagine giving it a line from a play. You can define a simple prompt, give it a couple of examples of what characters, emotions, or relationships look like. And LangExtract can pull those elements out. It nicely shows off its general text processing ability and how easy it is to define basically any task you want.
That's a neat demo. Like you feed it, Lady Juliet gazed longingly at the stars, her heart aching for Romeo.
Right.
And it could identify Juliet as character, aching as emotion, Romeo as relating character, and link them all back to the exact words.
Exactly that. But what's really powerful is how those same core principles translate directly to highly specialized, even life-critical areas, like medicine.
Okay.
The core ideas behind LangExtract were actually first developed for medical information extraction. It's very effective at processing complex clinical notes.
So pulling out things like,
Medications, dosages, symptoms, diagnoses, other attributes, and then mapping the relationships between them, like which drug is treating which condition. This was central to the research that led to this library.
wow, that's a huge leap from Shakespeare to patient data. So it's not just a cool idea, it's actually been applied in these high-stakes areas.
Absolutely. And to really showcase this, they built an interactive demo called LangExtract. It's available on Hugging Face.
LangExtract. Radiology, I'm guessing.
Exactly. It takes free text radiology reports, the descriptions a radiologist writes, and automatically converts the key findings into a structured format. It highlights the important bits.
That sounds incredibly useful. Why is structuring radiology reports such a big deal? What problem does that solve?
Well, think about it. Right now, many reports are just narrative text. Structuring them makes the information much clearer, helps ensure nothing important is missed, like follow-up recommendations.
Okay, consistency.
Yeah, consistency, but also data interoperability. Structured data can be easily searched, aggregated for research, used for quality analysis, maybe even feed into decision support tools down the line.
Right. It makes the data computable, actionable.
Precisely. It transforms those narrative reports into something that computer systems can readily understand and use. It's vital for improving care and enabling research.
That really highlights the potential impact. Taking hidden information and making it usable at scale. Now, speaking of medical uses, I know there's an important point we need to make clear here.
Yes, absolutely. A crucial disclaimer from the source material.
Right. So this medical extraction work, the LangExtract demo, they're purely for illustrating LangExtract's capabilities.
Correct.
It is not a finished product. It's definitely not an approved medical device. It's not meant to diagnose anything or suggest treatments. You should absolutely not use it for medical advice.
That's essential to understand. It's demonstrating the baseline technology for information extraction, not providing a clinically validated tool.
Okay, very important distinction. So let's bring this all together. LangExtract, at its core, is about tackling that information overload, right? Taking that chaotic, unstructured text
All those buried insights.
and transforming it into organized, verifiable, and ultimately actionable data. And doing it smartly by leveraging powerful LLMs like Gemini, but with crucial guardrails like traceability.
It's really not just another library for coders. It feels like a significant step in how we can all interact with and, more importantly, understand the vast amounts of text that surround us.
Yeah, the implications feel really broad.
I think so. This kind of tool represents a way to genuinely get valuable insights quickly and reliably from that daily data deluge. It's about becoming truly well-informed without being overwhelmed.
Finding the needle in the haystack.
Even when the haystack is millions of pages deep, it empowers that.
Turning information overload into an actual advantage, a shortcut to understanding. So here's something to think about. Consider how much vital information is still locked away in unstructured text in literally every field. Research, law, finance, history.
Everywhere.
What could a tool like LangExtract unlock for your specific field? How might having that structured, traceable data fundamentally change how you learn, how you make decisions, maybe even how you innovate?
It's a powerful question.
If you're curious and want to see more, the documentation and examples are up on its GitHub repository. Definitely worth exploring if you deal with text data. It's a fascinating look at the future of unlocking information.